Find the derivative of open bracket x squared plus 7 close bracket raised to power 5 open bracket 3x squared plus 9. At the end of this video, you will be able to solve this type of question very fast. You're welcome to Exam Scholar channel. If this is your first time of coming across this channel, kindly subscribe to this channel and click on the notification icon to get notified when we release video like this. What are we learning in this video? This video is a continuation of our logarithm and indices class, and we are going straight to learn calculus. So make sure you stick to the end of this video and watch this video to the very end, so you'll be able to learn calculus very fast. Now in this video, we are not going to learn all the basics, but I promise you are going to understand this video if you painstakingly watch this video. So I'm not going to bore you with first principle, with limits of function. I'm going to go straight to the business. Now if you want to learn the father of calculus, is Isaac Newton and Leibnitz. Isaac Newton actually worked on differentiation, while Leibniz works on integration. So now, without further ado, let's start the lecture. To ease your journey in learning calculus very fast, especially differentiation and integration, you are going to start by learning functions in mathematics. Now, the first function we want to talk about is polynomial function. The general expression for polynomial is y is equals to ax raised to power n. Let me explain this. Y and x are both variables. A here can be number, which is the coefficient of x raised to power n. This n will also be a number, a constant. A is a constant, n will also be a constant. So when you have a function in which a variable is equals to something like this, you call it polynomial function. Please master this. When you see this, you know that this is a polynomial function. Now, polynomial function is having different types. So we can start with the least one, which is the linear function in mathematics. Remember from coordinate geometry, y is equals to mx plus c. Now, linear function, you are going to have y. Example of linear function is you have y is equals to 2x plus 10, as you can see here. Now, in physics, can we have a linear function? Yes, we can have a linear function. Example of linear function is this formula. Can you recall this formula? This is Hooke's law formula. F is equals to Ke, where K is the spring constant, force constant. Now look at this. This is a number constant. This is a variable force, exactly proportional to the word extension. Extension is also a variable, while K is a constant. This type of expression is also linear function. Okay. Now we can have quadratic function under polynomial. When you hear quadratic, the power of the variables will not be more than 2. So the highest power will be 2. Unlike linear function that the highest power will be 1. Look at x here, the power is 1. Y, the power is 1. F here, the power is 1. E here, the power is 1. Unlike quadratic function that you're going to have the power of 2 square. So now y is equals to 2x squared plus 3x minus 3. This is an example of quadratic function. In mathematics, you also have quadratic function. Example is you have a is equals to pi r squared. You can see here pi is a constant that is approximated to 20/7. Now a is an area of a circle, a which is what? Variable, and r is also what? Variable. So this expression is quadratic function. We also have cubic function. Y quadratic is 2, cubic is 3. The highest one is 3. You have y is equals to 4x cubed plus x squared minus 2x minus 6. Now you also have this m is equals to n cubed plus n squared minus 3n. When the highest power of the variable is 3, you said you have cubic function. Now in mathematics, example of cubic function is volume. Now what is the volume of a sphere? Volume of a sphere is 4/3 by r cubed. We can also have quartic function. The highest power of the variable is 4 for quartic function. You have L is equals to 4m raised to power 4 plus 3m raised to power 3. Another one is A is equals to minus 10, B raised to power 4 plus 3 over B raised to power 5 minus 8. Now all these expressions here, they are known as polynomial function. And we also have quintic. The power is 5. This is an example of quintic here. Why are we learning this? We need to understand function very well, because we are going to be dealing with this when we start differentiation and integration. The next function we'll talk about is trigonometry function. Recall from your basic mathematics class when we talk about trigonometry, there are so many things that we used to mention under trigonometry. The first one is sine. Sine is a function. Now, the least function for sine, when you want to express sine function, you have y is equals to sine theta. Y is equals to what? Sine theta. This is the least expression for sine function. Something is equals to sine something. Now, sine function. Now, another example of sine function here is y is equals to sine x plus 2 sine square x. This is also a sine function. Now, let's go back to wave, and let's go back to simple OC circuit, wave, and oscillatory motion. You can see that y is equals to a sine omega t. Ya is the amplitude, maximum displacement. Omega is the angular frequency or angular velocity. Yt is time. And you can see this, that this is also a what? A sine function. We also have cosine function as well. For cosine function, the least one is also what? Y is equals to cos theta. Then you also have y is equals to cos x plus 2 cos cube x. And you also have this, which is related to oscillatory motion, vibrational motion, simple harmonic motion, and waves. Y is equals to a cos omega t minus phi. This phi is phase angle. Now, still under trigonometry, we also have tangent function. Under trigonometry, a is equals to tan theta, and then you have all this. This one are also called tangent function. Apart from sine, cosine, and tangent, we also have their inverse, which is also function under trigonometry. The first one is cosecant. Cosecant is the inverse of sine. Now, you can have this expression for cosecant function. You can also have secant function, which is the inverse of cosine function. You have this. Now we have cotangent function, which is the inverse of tangent function. These are the 6 functions that we have under trigonometry. We also have exponential and logarithmic function. For exponential function, these are an expression for exponential function. The least one you can have is y is equals to Euler constant raised to power x, and y is equals to a constant a raised to power x. Now, when you see this expression here, you know that we are talking about what? Exponential function. An example of exponential function in physics is when we talk about the K formula. The K formula in radioactivity, you have n is equals to Euler constant raised to power lambda t. Why this lambda is the K constant and t is the time. This expression is also exponential function. Now, this expression is also what? Exponential function. Please kindly master all these functions as I'm talking about them, because we need to understand them before we jump into differentiation. Now, we also have logarithmic function. Logarithmic function. For logarithmic function, you have y is equals to log a to the base of n. You also have y is equals to ln, which is natural logarithm x. Now, you have this expression. You have this expression. So when you see something like this, you know we are talking about logarithmic function. And when you see something like this, you're talking about logarithmic function and this exponential function. Now that we have understood different functions and how we can identify them, the next thing to learn is we need to understand that functions can come in multiple ways. So we can have mixtures of functions. So let's understand this very well. Now, how can we have multiples of functions? We can have different functions in which they are adding or they are being subtracted from one another. So let's say you have y is equals to a particular function plus or minus another function plus or minus another function, and so on. So in calculus, we can have something like this. So we are going to see an example for this. Let's continue. We have product of function. Product means function multiplying each other. So you can have a situation whereby you have a particular function multiplied by another function. It can be the same type of function or different functions. So it can be sine function multiplied by exponential function or logarithmic function multiplied by polynomial function. You can have this in calculus. You can also have functions of functions, which is also known as chain rule. Let me explain this very well. Human being can also carry another human being. A life can carry another life. So, which means function of another function. For let's say a pregnant woman is carrying a living baby inside her. So you can have this kind of situation while solving calculus. That kind of situation is known as chain function or function inside another function, function of function. So let's say you have y is equals to a particular function, an expression, and in that expression this f1 is also having another expression inside it, is equals to function f2. So this is called chain function. And lastly, we can have quotient or divisions of functions. So you can have a situation whereby you are given a question and you have two different functions dividing each other. So we call it quotient function or division of function. Now, let's look at something here. Now, let's say we have y is equals to sine x plus 2 sine square x minus ln 4x squared. Let's break it down. Let me explain something for you guys here. Now, from all this scenario, where can you classify this? You can classify this as sum and difference of functions. Okay, you have sine function plus another sine function here minus a logarithmic function here. So you can classify it as one. Now let's now talk about individual functions here. Now when you see y is equals to sine x, this sine x is a basic function for sine function, the least one. Now look at this one. You see that it's not the basic because we have sine square x. Sine square x means sine x multiplied by sine x. So you have 2 multiplied by sine x times sine x. So which means that this function as a whole is also product of functions. So you have 2 sine functions multiplied by itself and then multiplied by 2. Let's come over here. Now this is a logarithmic function, natural logarithm, isn't it? But the least one is ln x. But here we have ln 4x squared. Can we break it down? Yes. This 4x squared, as you are seeing it, it is also polynomial function. Now we now have ln, which is logarithm function carrying polynomial function. So which means that this ln 4x squared also fits into what? Functions of functions or chain functions. Now let's look at this one again. You have ln x squared plus 6x open brackets sine x plus 6 exponential x raised to power 30. Now we have 2 functions. You have these functions multiplied by this function, isn't it? That is what? Product of functions. Now let's now break it down. Let's break them down individually. Now ln x squared, this x squared as a whole is also what? Polynomial function. And here you now have logarithm function carrying polynomial function, functions of functions inside this whole expression. Now this one is also what? Polynomial function. Now come here. This is the least value for sine function, isn't it? Now when we now come here, this is an exponential function. Okay. Now let's look at something under exponential function. Now the least one is exponential x, but here we have exponential x raised to power 30. X raised to power 30 as a whole is a what? Polynomial function. So you now have exponential function carrying polynomial function. So that is what I need to explain to you. Now let's look at another one. You have x raised to power 30 plus 6x close brackets raised to power 10 5x plus x squared. Now let's analyze this. You can see that the whole of this is multiplying the whole of this, which is what? Product of functions. Right? Let's now look at them individually. You see that this one is adding this one, and here sum and difference of function. But now observe something again. The whole of this one is now having the power of 10, which is what? We have polynomial function here inside. The whole of this is also acting as what? Polynomial function, because it's carrying 10. Polynomial inside another polynomial. Now come to this one. This one is just a polynomial function adding itself. We also have this x to the power 3 plus 6x over sine x. When you observe this very well, you see that we have a polynomial function at the top adding itself. Now we now have divided by sine function. Now from the first explanation, you see that 2 sine square x, I'm talking about this guy, it means what? 2 multiplied by sine x multiplied by another what? Sine x. From this expression, you can use u to represent sine x. If you use u to represent sine x here, wherever you see sine x, put u there. You are going to get what? 2 multiplied by u multiplied by u. At the end of the day, you get what? 2u squared, which means that instead of putting sine square x here, you can have what? 2u squared. That is what I'm explaining. As you can see here. Now you have ln 4x squared. I'm talking about this one here. Let me explain to you why it's function inside another function. Now you can use u to represent 4x squared, isn't it? You now have ln u. You see that you have reduced this to the least logarithmic function. Okay. Now let's look at this one, ln x squared. You can use another alphabet to represent x squared. So you now have ln u, which function or logarithmic function. So let's come back to this one, which is also function of a function. Now instead of having x to the power 3, you can use u to represent it. You now have 6. This guy, you have constant raised to power what? Raised to power u. Now come back to this guy here. X raised to power 3 plus 6x close bracket raised to power 10. And when you come back to this guy here, you can also use what? U to represent this guy. When you use u to represent them, you have what? U raised to power 10. What is u raised to power 10? Is it a function? You see how we have reduced this to something like this using substitution. In a situation whereby you have functions related to another functions, like how I've explained earlier on, how can you differentiate them? Now this is the basis of what we want to learn in this video. Kindly master all these rules for me. Make sure you pen them down and you master them. The first one is when you have sum and difference of functions. How do you differentiate it? It's very simple. Now, like this expression, change in y. For this expression, we will now be individual differentiation of all these functions that they are adding one another. So you have dy will now give us df1, d plus or minus df2 plus or minus df3 and the likes. Sum and difference. The second one is when you have product. You have product of functions, two things multiplied each other, two functions. Now let's use u and v to represent those functions. So if y is equals to, you have one function multiplied by another function. How do you solve it? It's very simple. Now to differentiate y, your answer will now be master this. U dv plus v du. U dv plus v du. It means that you write the first one multiplied by the differentiation of the second one plus you write the second one multiplied by the differentiation of the first one. Let me come again. You write the first one multiplied by the differentiation of the second one plus you write the second one multiplied by the differentiation of the first one. Now let's say in the question u is given in terms of x and v is given in terms of x. So you can write this expression. So which means dy dx, changing y to changing x will now give us what? U changing v to changing x plus v changing u to changing x. We are still going to learn this properly. Just follow me and please master this and write them down. The next one is functions of functions rule. And you have multiple functions, function inside another function. Now, to differentiate it, let's say dy df1. What are you going to get? Where f1 is equal to f2. So your dy will now be what? df1 multiplied by df2. Let me break it down. So in a situation whereby you have function, let's come back here. Functions like this, whereby your f1 is inside another functions, or there's another function inside f1. You need to write out the two different functions and then you now differentiate them. So which means you are going to find the differentiation of the f1 as a whole multiplied by the differentiation of what is inside it, again df2. We are still going to look at this properly. Now the last one is quotient or division or functions rule or quotient rule. So when you have this kind of situation, how are you going to differentiate it? You use this formula. So which means dy will now be what? U dv minus v du. You see that it's similar to product rule. The only difference is that we have over v raised to power 2 here. So dy will now give us u dv minus v du over v square. Master this when it comes to division and you are asked to find derivative or you differentiate. You use quotient or division rule. Now to better understand this, let's start solving question and let's learn the meaning of differentiation. Now differentiation can also be called differential or slope and gradient. As I've said earlier on, I'm not going to bore you with the meaning. Let's just go straight to the point because that is what you guys want. Now, polynomial function, how do we differentiate polynomial function? Is very simple. If you have a function is equals to ax raised to power n, you see that this is a basic where your a will be a number, a constant, n will also be a number. This is a what? A variable, and this f is also what? A variable. How do you differentiate it? To differentiate it is very simple. So we want to have three things like this. Follow this animation. Now df, what is the variable here? X, and that is why you can also call it what? Df over dx. Change in f over change in x. Now what are you going to get when you want to find it? It's very simple. The first step is you carry this n, you bring it back. Whatever the power of x is as a number, you bring it back, multiply by this a. You can see it here, na, see it here, na. The next step is you will subtract 1 from n. You now have n minus 1. You can see it. So when you have this type of expression, which is for polynomial function, you bring this n back, you subtract 1 from n. So which means that if the original function is x squared, when you differentiate it, it will now become what? X. If the original function is x raised to power 3, when you differentiate it, it becomes what? X raised to power 2. Finally, so you have this expression. Now this is called differentiation for polynomial function. It's also known as differential. You can also call it slope. This is slope here, change in f over change in x. It's also known as what? Gradient. Now let's look at this simple example. Find the derivative of y is equals to x raised to power 3. Don't forget. So derivation, differentiation, derivative, differential, slope, and gradient all means the same thing. Now y is equals to x raised to power 3 and you are asked to find the derivative. So which means you want to find change in y over change in x. How do you solve it? I've explained. The first step is you carry this 3 backward. You now remove 1 from 3. As simple as ABC. So dy over dx, when you carry this 3 backward, what is staying with x? It is 1. 3 times 1, 3. And you remove 1 from 3, you have 2, 3x squared. This is dy over dx for this expression. Now, can we differentiate this expression once again? Yes, let's see how to differentiate it. Don't forget, we are differentiating dy over dx, abi, with respect to what? X. Okay, let's go. So you now have d over dx. You are differentiating this with respect to what? To x. That is why you have d over dx. Change d over dx of this. Now, do the mathematics. When you multiply d with d, you have d square y. Dx times dx, the whole of this is dx square. When you see them writing dx square like this in mathematics, it means that this square is for both d and x. So what I'm trying to teach you here is that you can differentiate an expression multiple times. So when you differentiate it the second time, it means that you have d square y over dx square. Oh yeah, differentiate this the second time. 2 will come back. 2 times 3 is 6. 2 minus 1, 1. So you have 6x raised to the power 1 or 6x. So in a question, they can ask you to find dy dx or d square y over dx square. Now that one will lead me to explaining higher derivative. First derivative or first differentiation, you have dy over dx. What about second derivative? You have d square y over dx square. What about third derivative? You have d cube y over dx cube. This is higher derivative. Now that we have learned how to differentiate polynomial function, the least expression for polynomial function, now let's start applying what we have learned so far in this video. So the next thing is, let's solve question. The first question, find the second derivative of y is equal to 10x raised to the power minus 3. Wow. This is simple. Just calm down. Calm down. Now you see this 10x raised to the power minus 3. When you use your previous knowledge, so if you haven't watched the 4 videos that I've released earlier on, go and watch it. Mathematics is not hard. So you cannot just jump ladder when learning mathematics. You don't know the basics and you want to learn. Go back to the basics. Go and watch the first video in this playlist. Move to the second one, the third one, then the fourth one, then you now come to this fifth one. That is how to learn. You don't jump when it comes to mathematics. Be serious. Go back. Go and learn indices. Now, in my indices video, when you have x raised to the power minus 3, what will happen? You remember that this one is coming from indices. Now you now have 10 over x raised to the power 3. You are still asking me, why is this? From the law of indices that I've just shown you now. Okay, can you now see? That is 10 over x raised to the power 3, isn't it? So instead of having 10x raised to the power minus 3, you can also have a 10 over x raised to the power 3, isn't it? I'm trying to teach you something here. Now, in the question you are asked to find the second derivative, so you need to find the first derivative. Okay? Now let's find the first derivative before the second one. The first derivative, you have dy over dx. What will happen to this minus 3 is going to come back. Minus 3 times 10, isn't it? Then you have x raised to the power minus 3 minus 1. I've explained it. You subtract 1. After you have bring it down, you now subtract 1 from it. Minus 3 minus 1. Now what is minus 3 times 10 here? You have minus 30. Abi? X raised to the power minus 3 minus 1. What is minus 3 minus 1? You still don't know this. Minus 4. Minus 4. Minus 3x is for minus 4. Now use the law of indices that I've explained. Something that looks like this. Now what will not be your answer? Minus 30 over x raised to the power 4. Come back here. I want to link things together now. I want to what? Link things together now. When we have minus here, minus 4 here for this guy, look at our final answer. It becomes what? Minus, and it increased by 1 in terms of minus. Minus 4. Don't forget that when it is plus, it's reducing. If we don't have minus 3 here, and let's say we have 3 here, our answer will be what? 30x raised to the power what? 2. But when it comes to minus, it's increasing in terms of minus. That is where I'm going. Okay? Now look at our final answer. We have minus 30 over x raised to the power 4. I want to teach you a trick that you can use to solve questions like this very fast without stressing yourself. When you see something like this and they ask to solve it, within 2 seconds, you can solve it. Okay? Let me explain. So when it now comes, when you have your variable at the denominator like this and it's carrying power, the final answer is you increase it by 1. When you increase x raised to power 3, it becomes what? X raised to power 4. Now because it is down, you will put minus. The same way you used to solve the previous one that I've explained. Apply it. Now you now have what? Minus 3 times 10. Is it now minus 30? Increase this one by 1. So x raised to power 4. Stress yourself. You are writing jam, for God's sake. You still want to be doing all this, wasting your time. If I see this kind of question, I already know that me, I will just carry 3. 3 times 10. 30. Because it is at the denominator, that will give us minus 30. Minus 3 times 10. Minus 30. I increase this one by 1. The final answer will now be what? Minus 30 over x raised to power 4. Or you convert it to this way and you apply the normal formula like this. Don't stress yourself. Now let's solve the second one. The second one is, you want to find the second derivative. Let's find the second derivative. You have this square y, which means that this one, differentiate it once again. Don't stress yourself. Just carry minus 4. There, multiply it by this. And you increase this one by 1. Minus 4 times minus 30. You have what? 120 plus 120. You increase this one by 1. X raised to power what? 5. Now I have minus 4 times minus 30 over x raised to power 5. Now I have 120 over x raised to power 5. Which is still the same thing as what? 120 x raised to power minus 5. You still don't understand? I will explain. Oh yeah, convert this one back. When you convert it, you have something like this. Differentiate it once again. Minus 4 will come back. What is minus 4 times minus 30? Is it not 120 plus 120? Oh yeah, minus 4 minus 1. Is it not minus 5? That we have here. Oh yeah, do your law of indices, for God's sake. You have 120 over x raised to power 5. Make you no stress me. I've explained law of indices in our mathematics playlist. Just go and learn it. So check out our channel. You see mathematics playlist. You can learn everything about indices. All right. What have we learned so far in this video? In this video, I was able to explain different functions. I explained polynomial function. We have linear, quadratic, cubic, quintic function. I also explained trigonometric function, all the 6 functions in trigonometry. Then we move to exponential and logarithmic function. I explained all their basic function. Then we now move to relationship of function when we have multiple function. I explained that function can add or subtract each or one another. I also explained that function can multiply each other, which is also known as product of function, and that leads to product rule that you can see here. Master this rule. I also explained that function can have another function inside it. So one function betting another function. So that is called chain function or function of function. So that one leads us to chain rule. Chain rule, how you can differentiate this type of function. Master that as well. I also explained quotient rule when function is dividing another function. So there is a rule for it. Please master the differentiation. Later on, we now talk about how to differentiate polynomial function. So your n will come back. Na x raised to power n minus 1. All right, that is all for now. Make sure you watch the next video. Watch it now. That is when we are going to apply all this. If you haven't subscribed, subscribe to this channel. And if you haven't joined our online community in which we used to have our online class almost every day in math, physics, chemistry, and biology, kindly join our online platform, as this platform helps a lot of students. All right, see you in the next video. Bye for now.